ideas, sex, gender, race, all of those are really examples of a category. And we're going to be really utilizing that quite a bit. Why is that thing saying that? There we go. So what we're going to try to do is really instill this idea of doing summary statistics for continuous variables like integers or even integers or real numbers given a category, and then seeing how those summary statistics differ from one group to another group. And that's really kind of the tool that I want you to think about taking away out of this particular series of this particular lecture. Okay. All right, so I think most of you know what we mean by summary statistics. This is probably nothing new to you. I'm gonna add a little bit of a nuance to it that over my years I've seen and heard and really seen confusion around. But these are a number of commands that you can run in R that will on a particular variable, that allows you to calculate the sample mean or the sample median, things like that. Some of maybe things that are new to you are this interquartile range, which is really the 75th percentile to the 25th percentile. So if I have 100 observations, what is this telling me? So if I just simply order things from 1 to 100, I'm going to have a 25th observation and I'm going to have a 75th observation. And whatever that is, I'm going to take those and that's going to be my IQR. Okay. If I've got 1,000 observations, then that turns to 250 and 750 if I have 1,000. So in general, that's the idea. It's going to take, what's the smallest 25% of your data set, which the 75% largest of your data set, and that's what it's going to tell you. Okay? Where these would be the min and this would be the max. And that's what you're seeing here with regards to the min and max. Range just gives you the min and max too in one outcome. And then one of the things that I don't show here that we're going to look at is percentiles, which allows you to get more specific with regards to your percentiles. So in this case, this is a 25th percentile. And this would be the 100th percentile. Well, let me do this. That would be the 75th percentile. Okay. And those will be more clear as we start to use them. Okay. All right, so here's an example on continuous and discrete variables. These don't work on categorical. In other words, if I'm talking about sex or gender or anything like that, means and medians and modes and standard deviation, none of these really make any sense from a categorical standpoint, but they make perfect sense from the standpoint of a real variable and integer variable. Same thing as we find here. So let's go and just simply kind of look at this. Let me load up my my particular workspace for today, and wanted to just simply kind of reinforce what we've been trying to understand with regards to how to use RStudio to figure out what a command does and what the arguments are and things like that. So there we go. So down in the right-hand corner, can you see that? Down in the bottom left-hand corner, is that kind of hard to get that up? Let's see, maybe I can do this.
Do we need the library VTAB also?
I'm gonna try to figure that out, whether or not.
We got the first four already going in the student code, but janitor and V table, I don't know if you're gonna go through that today.
Yes, I will.
Oh,
All right,
I don't know if I can get it installed.
so if I come in here, this is always a balancing act. I'm gonna hit. So we all know how to find the help function, right? We go ahead and do that and pull that over. Let's shrink this up. And then we have our help function. So this is the nuance I want you to understand. This is not the population mean, this is the sample mean. Okay. So what it's doing here is it's taking all the observations and it's taking that you have in your data and it's taking the average of that. And that would be the sample mean. That is an estimate of the population mean, okay? Subtle difference there, I think, but you need to understand that this is just simply the sample mean of your data. And as it says, you've got an X that's really just an R object, and so that would be your data. Trimmed or not, whether or not you take off the tails, which would be kind of like this, throwing away observations, and whether or not you're going to treat missing observations or not. And in this case, it does, it's defaulted to true, so to false, and so it's always going to include missing observations in the calculation. And you get the examples down here, and it shows you things that we've already talked about before. Okay. Now, each one of these particular statistics has a similar type of help function. So you can just simply hit, question mark, and now suppose that I didn't know what the command was for percentiles. Okay, so I haven't talked about it yet, so I say R code for percentile. There you go. So it's going to how to easily calculate percentiles on. Now this is just coming from statology, so let's see if this helps. So if I go in here and just look, there it is. It will give me quantiles here, which is pretty good. And it shows that in this case, I'm going to specify which particular percentiles I want. In this case, the 25th, the 50th, and the 75th. And I can just run that on the data set and that will work. And so I'm going to kind of need to keep this in the back of my mind and see if this is going to really work going forward. So let's just quickly go ahead and type in quantile and see what it says to us. Generic function quantile produces sample quantiles corresponding to the given probabilities, like a 75th probability, a 25th probability. But I have to specify that, where in the IQR function, I didn't have to specify that. It automatically gave me the 25th and the 75th percentile. So here I'm going to have to put in what those probabilities are. You can see it's a numerical value between 0 and 1. Again, because probabilities are a fraction, they're between 0 and 1. Does that make sense? And we'll be using that later on. And so if we think about what a median or a mean or things like that are really telling us, it's really trying to summarize what's going on in your distribution. Now, what am I assuming about my data if I draw that distribution for you? Kind of maybe a little bit of a hard question. Would that line up well with something like, a discrete variable, something like number of years of school? Would that kind of distribution line up with number of years of school? No, because if I'm thinking about number of years of school, what's the variable that I'm after? It'd be something like, well, 1 out to 12 would be for high school, and then 16 would be for college, and say 18 would be for masters. But the number of years of school would I ever like have 1.5 or 2.5 or 1 3/4 or 1.1 or any of that? And this is assuming that it's continuous. So how would I see what that distribution for years of schooling would look like?
So, this would just be completed. Years of schooling completed.
Right. How many years of school, or how many years you've currently had? So we did a survey, and here we would ask, how many years of school have you had? And that would just be a number in it. And so in this particular case, what you're gonna get is a histogram. Does that make sense? Where this would be like, 12. Because most people have a high school education. And maybe not as many that would have a master's degree or things like that. And this is assuming that, no, it's continuous. And so you have to kind of take that with a grain of salt, but the same concept here carries over to the discrete variable too. So we're not gonna worry about that when we do the calculations. Okay. So in this case, my mean and my median are the same number. When might you not wanna use the mean? Well, when you have a lot of skewness in your distribution, the mean and the median get very different from one another. In general, we report the median because it doesn't suffer from that contamination that comes from the skewness. And a classical example is income. If you report the mean level of income in the US, it's skewed way right because of a handful of Jeff Bezos and, Bill Gates and those people, but on average, those are like outliers. And so the median is gonna be much more representative of the population than the mean in this particular case. And so we can look at the median and the mean. If they're, a big difference, we can then use that as a way of saying, oh, it's positively or negatively skewed in terms of its distribution. And that's what we see here, is in this case, it's skewed way to the left-hand side, and that's causing my mean to be smaller than my median, and so I would say there's skewness. We could actually compute the skewness if we wanted to. So let's see if I can. So what is it, Brian?
Okay,
Oh, thank you.
skew power. That's a function.
That's not what we want. Well, this is where, if I'm working at it, I would then go here, go to Google, and say R command do for skew. Click on it, come down here. I need a package called moments. and then I had skewness, and that would then give it to me. So just an example of how you kind of would go about trying to solve that problem. We are not gonna be calculating explicitly the skewness, but instead just simply the mean and the median that would then help you to say whether or not there's skewness rather than the actual value of skewness. Another thing with regards to distributions is how spread out they are, which we refer to as variance or standard deviations. And that will tell us whether or not there's a lot of dispersion. In the research that I do, the spread is a measure of risk. The more uncertain things are, the wider the distribution is. And so you can apply that to any kind of both discrete variables or continuous variables. It just depends on the problem at hand. Doesn't work for categorical data, okay? And here are the commands that we've seen before. Also the range, which is the minimum and the maximum value, the quartiles, and then also this interquantile range. You can kind of see how this is going on here, where the variance and standard deviation of this particular data set is much tighter than what we have here. And so the standard deviation is 1 as opposed to 5 here. And that's telling you that there's a lot more variability among the individuals in this particular sample than in this sample here. Okay. Again, this is the sample standard deviation, not the population standard deviation. So now we get to categorical data. In categorical data, the summary statistics that we just talked about really don't apply. Okay. And where categorical data has relevance is counts. How many individuals fall in to a particular category? How many observations in your data set have this particular categorical characterization? And some of the research that I do, I have skilled mutual funds and I have unskilled mutual funds. Those are my two categories. I want to find out how many mutual funds are skilled versus how many mutual fund managers are unskilled. And so I want to classify them there and then count them. And so to do that, I'm going to have two categories, skilled and unskilled, and need to create that. And the way that I create that is with a function called factors. And factors is nice because it not only says skilled and unskilled, but then it's going to put a numerical value to those so that I can then utilize them in a numerical sense. You're familiar with dummy variables, right? That's exactly the only difference between factors and a dummy variable is a dummy variable is usually 0 and 1. Or in this case, if I have two categories, skilled and unskilled, instead of being 0 and 1 to define them, it's going to be 1 and 2. Sometimes I like that, sometimes I don't, and I'll change that depending upon the question at hand. And we'll have an example of that around marriage, because marriage is I'm either married or I'm not married, and they use 1 and 2 in the data set, and that doesn't allow me to do particular calculations. I would rather have it 0 and 1 for the reasons that you found with regards to the dummy variable kind of case. Okay. All right. So if you want, go ahead and load up your purchase data. So I need to do that here. So I'm going to go ahead and read in purchase data, and I'm going to call that purchase data. Whoops. Read CSV. I bet you I don't even have it in this. Nope. How many of you have your purchase data? How can I get that real quick?
If you wanna go into the class section,
Yeah, I don't have,
just download it real quick and then.
yeah, let me type that in there. So I'm gonna quickly go to Canvas. Gonna log into Canvas. Unfortunately, this account, this particular,
You can go back and pause, go back and pause it. Like, just do a new pause window, back where you were.
oh, I know what I can do. I think I've actually got it over here. Just data. All right, so I've got it now, I can go ahead and grab it. So I'm gonna go do what I've done before, and I'm gonna come over here and I'm going to, here we go. I want a new folder, and I'm gonna call it data, things that we've already done before. And in this particular case, I'm gonna upload a file called purchase data, there it is. Upload that and then I'll be good. So this is a redo of like 2 weeks ago. Right? Any confusion about what I just did? Okay. So if I come back over here and go to projects, I've got in my data and now have purchase CV. So this command here isn't gonna work for me, right? I have to add the data there because it's in that particular directory and execute that. And now I'm good. Any confusion on what I did? Be free to ask, because that was kind of just winging it since I didn't have that data already there where you should have already had that data. Brianna?
It's saying that it cannot find the function read, CSV.
Do you have tidyverse loaded?
Is your data or just in that project? Oh, shit, there's the data slash.
Yeah, I think it's not that the read CSV.
Like, it's this like this. Just return. Yeah.
Were you able to help her, Leah, then?
No. Oh, I don't.
Didn't work? Brian, do you wanna jump in there? and
Yeah.
see? Everyone else has the purchase data already. Okay, so there's a little bit of an issue here that I have not done, but I need to assign that a name. Dion?
For mine, it
So
says
we
that
can
it
do,
couldn't load
Do something.
tidyverse.
So go,
In the library command,
maybe get a little sign like this. and use this extra.
And install. And then type tidyverse.
Oh, thank you.
Escape key. So you want
You
to
gotta type
share
it all
Yeah, that,
tidyverse.
if you have any issues
Yeah.
and run code and
Okay.
you don't know why.
Thank
always
you.
check this first.
Yeah, that's,
If there's something
so,
like-
because you're in a new workspace, it doesn't have any packages from previous workspaces that you've created loaded, and so that's why at the beginning of class, when you load that script, at the very top, all these install packages should go out and grab them and do that compilation, and then library just puts it into
Oh,
memory.
you put read Excel, it's read, yes.
There you go, you're good.
Oh, okay. Thank you.
Now just do the, command return, and it should read it in. Brianna, you're good now?
I'm okay, thank you.
I put it in the
And-
manifest.
Dion?
Let me see if this is- Maybe we can do it for this.
So what I hadn't done is originally, I just had the read CSV and then the file name. I hadn't assigned it a particular variable name, so I need to do that, otherwise I'm not gonna be able to really do anything with it. And if I come over here and look, at
Oh, should I?
my environment, now I have the purchase data showing up as a particular, data file, that has 11 objects and 2 variables. So, this kind of goes back to, I imported it, now let me visualize it. And to do that, I'm gonna use the str command. And if I go ahead and execute that, if you look down here at the bottom, you see that this particular data structure has 11 rows, 2 columns, and the first column is labeled store, and the second column is labeled type, where that store is denoting to the particular store of Walmart, Amazon, Best Buy, and so forth. There may be others, I don't know, it's not really telling me that, it's just giving you the first 4 observations. And then it's telling me for each of those stores, whether or not it's a physical store, brick and mortar store, or whether or not it's a virtual store like an online store like Amazon, right? Does that make sense? So I'm getting an understanding of what's actually in that data initially. And then, by just using the str command. Dion, do you still?
Now I'm getting the same error that Brianna was getting.
I'll take a look.
Okay, thank you.
And so, one of the things there is both of these are categorical, right? There's no real values here, and so all we're gonna be interested here is thinking about in the context of how many I have in each of these categories. And that's where we're gonna be using very L to be able to command to do that. But before we do that, we wanna use another command called factors, because right now, all I'm getting is strings. Does that make sense? These are just strings. And R doesn't know that one string is the same as another string in this case. And so what I'm going to do is I'm going to use factors, the command factors, to convert the characters found in type into, not convert them, but associate them with a numerical value, like I would like a dummy variable. Okay, so how do I do that? Well, I'm gonna use the factor command. So let's figure out what's going on with the factor command. With that, pull this over. So the function factor is used to encode a vector, in this case, that type vector, type of store, as a factor, in other words, a category, and it gets enumerated. Okay. And in this particular case, it comes with the vector or the variable that has characters in it, and then I'm gonna give it levels and labels. And in this particular case, all I'm gonna do is actually give it levels associated with the particular labels that it already has. So, everyone okay? Everyone's got their, Taylor?
What do you mean by levels?
So that's gonna give, which one's first and which one's second.
So R, if you leave out that levels piece, R will just automatically assign a level based on where, alphabetically. But when you're generating tables and charts and stuff, you may not want alphabet, you may want, we've got store and online, you may want store to be the first factor level, right? So you can explicitly declare like, look, I know you want to sort this alphabetically, I want this one first.
And it's also a way you can go back into your code, once you get your results, and interpret them and know that the things are lined up the way that you, because I could have it, I don't know, maybe I want males first and females second. Or you're more interested in females, and so you put females first and males second. It's just same kind of way that you define a dummy variable. It's gonna be driven by the question that you're after. Who do you want as kind of the base case relative to the non-base case? So, you can see some of the argument, kind of the way that it's used down here. So in our particular case, I'm gonna come in and I want to change type from just characters to a factor. To do that, type into factor from characters. Okay, and to do that, I would go temp. Does everyone know these tricks? So if I go control hyphen, alt hyphen, it gives me a assignment variable. So I don't need to be doing less than hyphen every single time.
You said
Alt
Option,
hyphen,
option or no?
Oh, it's option.
Oh. Yeah, translation to Apple. Did it work?
Yeah.
So you can't see that, but so instead of having to do 2 keystrokes, I just hit Alt. What is it for you guys?
Option.
Option
Dash.
hyphen.
Option dash.
Yeah, dash. Okay. So. What is it? It's option
Option dash.
dash, option dash, and that's the same as, does this make sense, as the horrible one. We should just throw those away. As that. Does that make sense?
Yes.
These are equivalent. Another one that you should know is, I know that this is Control Shift M is the same thing as
A pipe.
the pipe command.
Control,
that's way
shift, I'm
So I get really tired of typing, as you can tell from my typing.
Our coders are notoriously lazy, so we figured out a bunch of tricks.
So, okay, so I want to then take the type and convert it into a factor. So, I type in factor, I then type in purchase data, and what variable am I interested in changing? Type. And then I go, levels. And the way that I do that is I create a vector of the variables in the order that I want them in. So in this particular case, I'm just gonna follow the same ordering under here, store online. So store is gonna come first. And then, online is gonna come second. And that will work. Okay, now notice, I'm using temp here first of all, because I hate to do commands that would write over the original variable before I've got it right. That's just good coding practice, because if you write it up, if you write over it, it's done, and you have to start all over again. So I always do things on something new rather than and assign it, give it a new name. I could have just simply said purchase data $type here and made the change automatically, but then if I didn't do the commands right, my original data set's been changed, and then I need to start all over again if it wasn't right. All right, so I go ahead and execute that. And if I come over here, and I'm gonna just do it down here because I'm not really interested in it. If I execute this str command, can you see that? Or is it too far down? Notice what it's done. If I look at it here, type, character, has 11 values in it, and they're all strings. Now it says, oh, you've taken what was typed, and now it's a factor with 2 levels, okay? 1 and 2 being those levels that are assigned to store and online. So now I've got numerical values associated with those characters, those categories, that then allow me to do calculations around them that I wasn't able to do when they were just strings. So I'm getting the result I want now. So since I'm getting the result I want, I'm gonna come back and I'm gonna go ahead and change the data. I'm gonna go ahead and change what it actually has there. And so I just simply come up here and I'm gonna copy this. And instead of having temp there, I'm gonna put in purchase data type. Go to the end of that and execute it. And now let me come down again to the bottom, and now I'm gonna type str purchase data, see if that, and sure enough, look, my type now is a factor with 2 levels. So factors is a command that you would use. Look, if I looked at my data set that I read in and I executed this str command and I had factor on my categories, do I need to do anything? No, I've got it the way that I want it because it's got that factor representation. The only time I'm gonna use that factor command is if I do the str command and it comes up as just being characters. And I need it to be something that has actual values, and like we've got it now. All right. Let's come back here. And these are all found in the slides, things like that, so you can go ahead and review it there. Everything that we've done in our studio is found here. So, like I said earlier, it doesn't make a lot of sense to use a lot of the summary statistics on categorical data. It just doesn't make any sense. But it does make sense to talk about the number of observations falling into that particular category, right? That's very helpful to know what proportion of your population is falling into that subpopulation. How many males versus how many females? If I then break that down into males and females and how they fit into, say, levels of education, things like that, I want to count. And so I can do it not only for the individual variable, but I can do it across variables. And so the command that's going to be very helpful here is this tabbyYL. And tabbyYL is part of the janitor package. So you need to make sure that the janitor package has been installed and then the library loaded in order for that to happen, okay? So. There we go. So up here, I've already gone ahead and installed it. That's been executed already. And then I loaded it by issuing the library command for Janitor. You should already have that because the script that we gave you should have included that.
It might not have had janitor V table, so you guys may need to.
Yeah, this is gonna be,
Yeah, the last two.
yeah, it doesn't have this. So if you haven't done this one, go ahead and just execute that and then execute the Janitor library. To be able to get to the very I don't know why I call it Barry. I mean Tabiel. How do you call
Table.
Yeah, instead of writing it.
Yeah, it's like, they use that like the social media style notation. It's like,
That's a generational
it's
thing.
like Twitter and.
I'm offended by that.
So should we install VTable now?
Yeah, if you've got, why don't you go ahead and do this, do the vtable command too, and load it. So I'm gonna go ahead and type in my comment of example with just let me know when you're comfortable with me pushing ahead. So this is a question I want for Brian.
So,
It really bugs me that our studio is always at the bottom and it doesn't. You have to do
I mean, the.
carriage returns to get it to move up. It doesn't bother me when I'm doing it, but it drives me crazy when I'm presenting it.
Yeah, that's always an issue. It only displays the number of lines that you.
I know, I just
usually-
want it to just display.
Just keep going.
Yeah, and then I just work within it.
Yeah, I always end up taking whatever my last line is and then just adding like
Well,
10 characters.
There's a takeaway. I'm sure there's a
That's all I got.
solution. I just haven't
There
bothered to
is.
find it.
I think that's it.
Alright, so can I go ahead? Alright, so if I come in now and let's do this. Down at the bottom, I wanna go ahead and enter that and just see what this function does for me. So specify a data frame and the 1 or 2, 3 unquoted columns names you want to tabulate. Well, in this case, I only have 2, but let's start with one of those names. And in this case, I'm gonna use, let's do the store first, okay? And the way that that does is I need to go ahead and start with a data frame. And in this particular case, it's purchase data. I'm then going to pipe that to that table function. And in this particular case, the argument it takes is variable 1 and then the name of the variable inside purchase data that I'm interested in. I said store, so let me back up, okay? And then I can go ahead and execute that. Are we okay thus far? If I execute that, you can see at the bottom what I get is I get the categories that are found within store, and then it tells me the number of, of the number of observations within that data frame that fall under those categories. And then it actually gives me the percentile, or the percent of observations that fall within that too. So it's a quick, easy way to, one, it tells me how many I have, how many categories I have, and two, it tells me how many observations fall within that category. So how would I do it for type? In other words, figuring out how many stores are online versus brick and mortar stores. Any ideas? I would just change store to type, so I'm lazy. So I just come up here, I copy that, I paste that, and I just change that to type. And I hit Control, Return, and I get that in this particular case, I only have two categories, a brick and mortar store or an online store. And I've got 6 and 5, and that makes sense because I only have 11 observations. Lauren, can you see that? The bottom part?
Yes.
Because I don't think that helped much.
I'm getting an error that's saying there's not a function called table.
Did you
Did you run the
load
library?
janitor?
Yeah. I installed Janitor.
So how do you check and make sure that you have the library loaded? You'd come over here and you'd go into packages and then go down and see if janitor, they're in alphabetical, so see if janitor, see if it's not loaded. There you go. Now try it.
I'm getting an error.
I think it's the same thing. So come over here to this package and scroll down and see if janitor is highlighted.
Okay,
Bingo.
thank you.
And this is why we do it in class, so that you're not banging your head against the wall, trying to figure it out for an hour and a half. Leah, did that work? Now you were able to run it?
Yes.
So another thing that we can do is we can then come in and look at how the categories are kind of, I wouldn't call it correlated, but we can add, in this case, we only have two variables. So in addition to type, we can then include a second variable, store, and see how many are in that intersection. So in other words, how many Amazon stores are not online? Does that make sense? That are brick and mortar. So to do that, I use the same command as I did earlier, but instead of just variable store, variable 1 store, I'm gonna type in variable 2 is equal to type. And that gives me two variables, and then it's gonna tell me what their combinations are. And so we get this output here. So are there any Amazon stores that are brick and mortar in my data set? No. They're all online. And Best Buy does not sell over the internet. At least the stores that I have in this particular data set. Okay. Now, before we got percentages, which are kind of nice because, we understand percentages. We can think about it in terms of, oh, I got 75% of my sample that happens to be brick and mortar or whatever, right? And so it'd be nice to be able to put these things into percentages. And I can do that by just simply using what's known as the Dorn percentages command. So I'll put in note not in no percentages for store type, use adorn percentages. So let's do that, okay? I'm running out of space again, so. So in this case, I basically do everything the same. I'm just gonna take what's found here and I'm gonna pipe it now into that function adorn. And you can see it's right here. So I can pull it up, highlight it, and it says, this function defaults to exclude the first column of the input data frame, assuming that it contains descriptive variables, but this can be overridden. Okay, so kind of it starts there. The question is, what do I use for the denominator? Well, this is, if I come back here, I've got rows and columns, and I want all of it. So I'm not gonna specify row or column, I'm gonna actually specify, in this case, all. So put that in, and denominator is equal to, that's a nice thing to see. See, as I type it, I see I could have it as a row, column, or all, and I want it for everything, not just a row. I mean, not just for a column, but for everything. So it's a string, and I just type in equals all. Go to the end, execute that, and notice now I've got it in percentages. If you wanted. Questions, Dion?
I'm still getting the same error message.
But now on adorn percentages,
No.
does it work? Ryan, do you wanna? Keep going? Taylor?
So what is this percent like? How do you
This one.
interpret this?
So of my sample, 0% of them fall in a store Amazon category.
Yeah, if that ever happens, do Command C.
Where I've got
Freak out.
27% of my sample falls in a Walmart that's a brick and mortar store. But it's for the entire sample. Let me come in here and say, okay, let's do the same thing as what I have here. But now, let's change this all to,
There you go.
Thank you.
Fine.
I think it's called, yeah.
What does call stand for?
What the denominator is, and so what it's doing is it's looking column by column rather than the whole thing. So in this case, 60% of my online stores is in Amazon. In my sample, 60% of my sample is an online store in Amazon, whereas there's only 20% that are online in that. So I have to read it this way. I cannot read it between these, where this is the whole, this is looking at it from the store. So if I come up here and I change this to row, I would then be saying, okay, what percentage of Amazon is in store versus online? And we know that in some ways that kind of works because of the way it's specified, but let's just do that to kind of point out how it differs. So
60% of the online stores are Amazon.
yes, 60% of online stores in my data set belong to Amazon. Now, if I do row, I get this. And so now I look across, because it's row, and what does this say? 100% of Amazon stores are online in my data set. Keanu, did you get everything?
Yes.
No, we're not in a hurry. We've covered like 10 slides in the last,
90 minutes.
well, no, in the last like 5. Give me
Depends
a
where you wanna
break.
start, which is where you wanna start from, Mark.
Where are you? Brian can't see that number.
It's 10:26, that's all I know.
Well, that means it's time for a break.
It is. It's time for everyone to get a
Really
donut.
bad
Or a munchkin.
when your analyst is the one wanting a break and he's not doing anything. So, the cafeteria is open downstairs if you wanna go grab something.
Is it? It's 10:30,
Are they not?
yeah, they're gonna open until 10,
They're open till 10 and
and
then
then
they're not
they
open
open
till 11.
yeah.
There's donuts left. Let's try to come back at a 22, right? 10:40, is that okay? I'll give you, is that okay, Leah?
No, it was, I was like, it's 10:26 already, it was just.
10:40 good? Okay, I did say 10:30.
Yeah, it took me a second.
Why did I do this?
I think it's like, I think we just
gotta cut out the little white area. Oh, shit. I'll do this later. I'm also taking. Cause I feel it for
The text almost like feels like it's part of the background, and not part of what you added.
No, but she said, you have to do 50 pages.
50?
Yeah.
So,
50.
I thought it was 30.
some of the stuff that we did with regards to category counting is a natural feature of commands that you learned last week. The group by and the summarize, that is like meat, potatoes, stuff that you would use throughout your project. Depending upon what you want to compute by groups. And that's a really good skill to have. And so, let me just quickly show how this can be applied to reproduce what we had done. Here, say, let's look at just store. So, nice. If we want to just look at the category of how many stores are in my data set, I can then group by the category store and then just count them inside the summarize command. So let me do that here. So I would type in like equivalent group by and summarize approach to okay, so I'm gonna use the same data set. And I'm gonna pipe that into my group by command. Because that's where I want to separate out in terms of the categories. And in this case, I want to think about it in terms of the store, and so I'm gonna put in store as being group by. Okay. And then that then gets piped into the thing that I want to calculate. So you can use S or Z there, it doesn't matter for summarize. Kind of buffers me, so did that. And so if I look at the result down here by store, I've got 3, 2, 2, 4 as being the number of observations. Does anyone remember what the command in summarize is to be able to get the number of observations in a particular group?
Count equals n.
It's that n function. So, I need to call it a name, and then the result I need to call a name. So let's just use number of observations is equal to n, like that. Is that okay? And let me just go ahead and run that and let's see what happens. Are we okay with that? So if I come up here, remember it's 3, 2, 2, 4. 3, 2, 2, 4. So I get the same thing. What didn't I get by doing the group by summarize? I didn't get the percentage, right? I didn't get the percentage out of the sample that fall into each of these categories.
What package is this under?
This should be tidyverse.
Okay.
So go over to your packages and scroll down and make sure that tidyverse
It wasn't, alright.
is been installed and loaded.
Okay,
Everyone okay with that? So let me go back here. And so, any ideas on what I could do to what I've done already in the summarize command that would allow me to also have the percentage of the sample that falls into each of these categories of stores? What do I have to do to these to make them percentages?
adorned percentage.
Okay, that works here, but now I need to just think about it mathematically.
Divided by the total.
Okay, so, very good. What you said is exactly right. So up here, I'm going to do another command in my summarize, because I want it to be applied. And you told me that I need to divide it by the what?
Total.
Total. So I can do that by saying, so what would I call it? I'm gonna call it percent is equal to, I still need the n, right? I still need to count how many are in each of the categories. But now you just told me I have to divide it by the total amount. And so of observations. And there's a command that will allow me to add up all of the things that are found there. And so I can use the sum command, which is gonna sum up everything. And what do I want to sum over? The number of observations. So does that, do you think that will get it? You think that that will work? This one just simply counts it in each category. This one is gonna count it in each category, and for each category, it then sums up all of these to get that. Now look, I know what this is. It's
Percent. Don't you have to multiply it by 100?
Say it again, Taylor.
Don't you have to multiply it by 100 to get?
If I want it in if I don't want it in decimal between 0 and 1. But look, all these are between 0 and 1.
Okay.
And that's generally what we want. Fractions are, or decimal or, you know, easier to work between 0 and 1 than a 0 and 100. That's just,
Usually when we go to display things, we're gonna plot them out, then you can do the multiply by 100. Makes it a little better.
so when I just issued this part of the summarize command, I got 3224. Now I'm gonna say for each one of these numbers, because that's what number of observations is giving me is the 3224, I'm gonna divide that, say the 3 by what? The total sum of this. And the total sum is 3 plus 2 is 5 plus 4 is, well, plus 2 is 7 plus 4 is 11. So that should work, right? So let's see. Okay, so if I just execute that, clearly it didn't work. So what did I do wrong?
Can you guys guess?
Sum all.
No? What did we do? Yeah, go ahead. I think you got it.
I was just say like, I feel like you have to like mutate something and then.
That's right, because what we're doing up front is we did a group by, right? So if you think about that split, apply, combine kind of framework, it split everything up by the store name. And it's calculating that summarize based off of the store name. So we need to step back out of that group by, and then he's right, do a mutate. We can do this as a mutate. So can you guys think of what the command would be to ungroup something? Ungroup, that's exactly right. Ungroup. So after the summarize, we'll close out that parentheses, we'll pipe it to an ungroup, and then we'll do a mutate and then do that perk calculation.
You shouldn't have to ungroup.
You're doing it by group.
No, because I still, here's my data frame that I'm getting as a result of what I started with.
Yep.
And so now all I need to do is take this and divide it by the total number of observations. So what I messed up with is I didn't close out this.
Yep.
And now I'm just not thinking about this as being a new variable.
But
Mutate creates a new variable. So that's what I missed, is that if I close this out, now my summarize is done. If I then pipe that,
Are you saying you didn't create NOBS as a variable?
no, I have. And that's what's gonna come out of this. This last command created this. Now I'm gonna take that data frame. That's a new data frame, and I'm gonna mutate it and add a new variable to it,
Okay.
right?
Mhm.
So, I go mutate. I piped in that data frame, and then I just have to create the new variable that I want. And here I don't need to use my n command, I need to use my nobs command. I'm gonna delete that. Make sure I'm okay. Yeah, let's see if that works. And now I get it. Because before, I tried to do it all within the summarize command and I can't do that. You could possibly do it, but I'm not sure if my head works that way.
I like doing the ungroup just to be explicit, because as you get through these projects, you're doing a lot of groupings, you're doing a lot of multiple groupings. But either way.
And so these numbers will be the same that we had earlier, but that's the way that you can use this group by, summarize, mutate. That's, like I said, that's bread and butter stuff. That's the stuff that you'll be using constantly. Alright, so let's go back. Here. And that's, again, what we just done, so everything's there, maybe different names, things like that. And now what I wanna do is I wanna start thinking about how we can then apply these summary statistics on real variables that are conditioned upon being in a particular group. And that's really where we're gonna spend the rest of our time. So the CPS data is the next data set we're gonna use. A lot of the times when you get a new data set, this is kind of what you'll be doing when you get your data set for your research project, is these questions around, you know, who it's addressing, where it came from, what time period, when, what time period it covers, or what year, and then the what is really teased out of everything that's involved in it, and why. So how, you know, what is it actually calculating and things like that. So just kicking the tires on the data set, seeing what it is, doing summary statistics leads to a lot of additional questions that you may have not even thought about. I would say more than half the time, for me, the research question that I start out with is not the research question that I end with, because as I start to play with things and get to better understand that original question, it then develops more questions and that are more insightful and more meaningful and that have better not better results, but are more important to say policy decisions and things like that. So let's jump into this and let's go ahead and start looking at this CPS data. Okay, so it's included in the AER package. You look at all your packages, it should be highlighted like mine is right here, checked. If I go over here and I just type in CPS, you can see it has 1985. This is a quick way of starting to answer some of those questions that we just looked at. So it's a cross section. What's a cross section? What's the difference between a cross section and a time series?
So time series is like over time, and you get to compare the two sets.
And so you said that a time series is over time. What's the complement of that? That's a cross section. Cross section has no time variation. So where is it getting its observations? It's looking at a point in time, and what, in this case, it's people. It's a number of different people in 1985 that responded to this population survey. And that's why it's a cross section. If I looked at those same people in 1986 along with 1985, it would no longer be a cross section, it would be a panel, because it would have the cross section plus a time dimension to it, and that creates a panel. In this case, we're only looking at what the survey results were for 1985. Some of the data that you'll have on your project is probably going to be a panel. It's going to have a longitudinal study in the sense that it's looking at not only individuals, but also those individuals over time and seeing how things have happened. So we know that this is a a cross section, conducted in 1985. And you'll notice here it's going to have wages, education, experience, ages, and it's telling you. A lot of times we refer to this as a data dictionary, that tells us kind of what each variable represents. As you can see, this is wage dollar per hour. It's not how much salary they make, it's how much they make per hour, how many years of education they've enjoyed, and then experience in the workforce, how old they are. Their ethnicity is divided up into just 3 categories. Region is either they live in the South or they don't, gender, as you can well imagine what that is. And then the occupation as technical services, offices, sales, management. And then another area is they've got union as being, or married, okay? So I need to load that data. How do we load, a data set that's already found in a package? Just use your data command, and there it is. It's a string, so I do that. I'm gonna go ahead above it, hit a couple of returns, put in a comment of, CPS 1985, examples. And then I'm just gonna return that. And over here, if I come back to, this top one, my environment, I can see that it's loaded. How many different people do I have in this data set?
534.
Yeah, so I've got 530 individuals, those 11 variables that we kind of talked about already. Okay. I love my str command, so I will come in and do that. Do you know why I do it down here? Because it's really just stuff that I'm just not, I just want to do it to confirm to me. I'm not really going to be rerunning it later on. And so I can see that wages, that's a continuous, right? That's a continuous value. Education, integers, experience, integers, age, integers, ethnicity. What is that?
Factor.
It's a factor. Do I have to worry about it? So it's got 3 levels: Caucasian, Hispanic, and other. And so 2 would correspond to Hispanic, 1 to Caucasian, 3 would be other. Okay. Now, one thing I did show you, but I think it might be helpful here, is if I go in and let's just look at the first few rows of the data frame. On, let's say, region. And I printed it out, and it came out to be other. Did it give me a number? It didn't. But because it's a factor, each of the others are associated with, meaning the non-South, right? And so that's why looking at these and seeing that they're factors, I get that out of the str command. I do not get that out of listing the values inside the particular variable. Brianna?
Could you just remind me what is the $sign?
So in this case, I have a data frame that has a number of different variables. And to get to one of those variables, I can use the $sign followed by the name of the variable. Remember, I could use select is another way. I could have typed in, well, let me just show you. So I could have done the same thing here as head, select CPS 1985 region. I get the same thing. But in this case, I just selected one. The nice thing about select is I could have selected a number of them, a number of the variables found in there. $sign just gives me 1. Am I missing anything there, Brian? Okay. Okay, so just visualizing my data, things like that. And now what we wanna do is we want to do a summary statistic around, say, some of this. Well, I think there's a step between that. Let's, got this, got that. Let's go ahead and compute a summary of the real variables. So the real variables are integers: wages, education, experience. And this will come back to what Brianna asked just a second ago. So I can go ahead and take that CPS data, and I'm gonna pipe that into my, well, actually, I'm gonna select just those continuous or integer variables: wages, education, and age. Okay, and so that's just grabbing those variables out of that data frame, and that's what I'm gonna use in my calculation. So I pipe that into my summary command. So all I'm trying to do is really get all those mean, medians, variances, standard deviations, all that kind of stuff comes out, okay? And then I just simply control return there. And we get what's found at the bottom here. Better. So this would work. And so we get the minimum value, the maximum value for each of the few variables. You get the median, the mean, first and third quartile. This is the 25th, this is the 75th percentile. And what can you tell me about whether or not this, say, wages are symmetrical in distribution? Lauren?
So when I read the last part, it says that it can't be, it must be a simple vector, not a matrix.
The summary command? Is it summary or summarize? Should be summary. Anyone else having a problem with the commands 75 through 77? And we're okay with this?
Yes.
Can you tell me which, is there skewness going on in wages?
Yes,
And how did you figure that out, Taylor?
because the minimum is $1 and the maximum is $44.50.
Another way of seeing it is, look how big the difference between the 25th and the smallest value is compared to the biggest value in the 75th. Here it's barely 4. Here the thing is 33. So that thing's way skewed to the right. You also see a little bit of that in the mean and the median. The mean is bigger as a result than the median. So there's quite a bit of skewness. What about here? Not as much. 6, 3. If anything, is skewed which way? Downwards. Is it surprising that the median level of education is 12?
No,
Because you would expect that on average, everyone graduates from high school. It's suggesting that the population as a whole, on average, goes to college but doesn't complete college. And then age, gives you an idea of where it is. It's probably pretty symmetrical. So, other than the fact that, most people don't work before they're 18, at least in this sample, right? All right. So that's what we get there. Now, what I wanna do, and there's another way, I think that this is actually, this sum table is where you need the V table. And it's just a way of, instead of looking things in column format, like what we have here, see how is everything, you've got the variables going across, but the reported statistics going vertically. This would show you things horizontally. And some people like that. I actually prefer in a table to have them like this. Another thing is later on, we'll have a particular function that will allow us to make this very clear, clean and concise in a table format that you would use in your project reports. We'll get to that. So one thing that's different as a result of working with categories is that the summary command then stops thinking about means and variances and standard deviations, and it starts to think about it in terms of categorical, and that's when it comes back to counts and things like that. So if I do the same thing now that I did up here for wages and education and age, but now instead, let's just simply take ethnicity, region, and gender and see what it does there. So I'm just gonna, again, be lazy, go ahead and copy that, paste it, but I'm gonna change the variables that I'm interested in to those categories of ethnicity, region, and gender. And then run that. And so how did it change because of it being categorical as opposed to reals or integers? Well, now it's looking at it from a count standpoint. And it's telling you what the ethnicity is in terms of counts. So Caucasians, there are 156 versus 378 between the region in my sample between of Caucasian and Hispanic. Gender, we see that you get this division between in the sample itself. Ethnicity, because I have 3 different ethnicity, you can say that it's dominated by white Caucasians.
So this is like, putting it into groups based on the category, not.
Right.
Okay.
Right. Because remember, when we look, so in the real and integer space, you can do means and you can do variances and things like that. But that doesn't make any sense in a categorical context. What makes sense in a categorical context, if that's all I'm looking, is the number of counts within that category. And that's what the summary command is giving you back. All right, so you kind of see this. I didn't do age, but you can see it would also do the same thing. All right, so let's go ahead and start thinking about conditional summary statistics, like a mean, but condition it on, in this particular case, whether or not this individual was in the South or not. So let's find out whether or not the average wage in the South relative to the average wage of not being in the South, and seeing if there's any difference there. So if I come back here, I'm gonna condition on region. How do I do that? Well, I'm gonna take the original data that I have and I'm gonna pipe that, into my group by statement. And how do I want to partition my data? Does that make sense? Partition means that every observation either goes in one category, it goes into one of the categories. In this case, I'm really interested in region, so I wanna group everyone in non-south or in south. There's no in between here. And so I'm gonna group by region so that that's the way I split up my sample. And then what do I want to do? Well, before I asked about, well, do you think the wages are different for someone who works in the south versus someone who doesn't work in the south? Well, that means that let's start doing some summary statistics around wages by grouping. And so I'm gonna use my summarize command, and I'm gonna just start creating variables. So, what do I wanna call it? This is where I always get stuck. Think of a good, let's just keep it simple. Let's go mean wage. And that's going to be equal to the mean of the wage, right? And let's go median wage. And that's gonna be equal to the median wage. And it's because this summary, the summarize command is working on the groupings, it will do the conditioning for itself. And what's another statistical summary that you guys are, well, you know, that you're familiar with? What about the spread part of this thing? What captures the spread? Let's go with the standard deviation. Okay, and that's the wage. I'm not gonna do the variance. What about coming back to this? We could go to the IQR. So, IQR of wage is equal to the IQR. And this is where I'm gonna do, say, the percentiles. And that's quantile. Let's do quant wage equals quantile probs equals C. We're gonna go the 5th and the 95th percentiles. I think we're good there. You want me to, and let's give this thing a name. CPS wage region.
Is that 0.05 and 0?
Yeah, this one here is 0.05, which is 5%, and I'm making it symmetrical, and that's why I'm using 95%.
Oh,
Yeah,
So is that telling us like the percentile?
it's gonna tell me what the value of wage is for the group that will match up with the 5% and the 95%.
Okay.
When I read it, it says error.
same.
All right, do you think I'm gonna get an error?
Yes.
Yeah, so that quantile thing is gonna give you some issues, Mark.
Error.
That was something I added on the fly.
I know, I liked it, but it's not gonna run. So I think what you can do is you can specify unique quantile instead of having like a vector, because it's gonna return a vector that needs to go into,
Oh, I know.
yeah.
See, here's the problem. This guy, needs to be just a single value.
Yeah, so if you like.
And this guy, if I put 0.05, it would work. That, in fact, that,
Well,
Thank
that's
you.
the
Thank
first
you.
problem. The second problem is you gotta put in wage.
yeah, yeah. So, this is how I do it. Wage, probs, delete, C. Thank you, Leah. And I'm gonna do it this way. This is I'm gonna put 5 here and then, and go here, quant 95 wage equals quantile wage. Probs equals 0.95. Moment of truth. No errors. Thank Brian for that, and Leah helping me out. Okay, so it ran. Now let's come down here and print it out.
I think it's something with the parentheses.
So who got it to run? Dion's amazed. Dion is a little surprised it ran.
It ran,
Did you get these?
it ran, no. No.
Oh, it says object wage not found.
Something wrong with my.
Did you feed it this? Did you make sure you piped this in?
Yeah.
And then you group by region,
Uh-huh.
And
Oh,
then-
wait.
you should have a wage variable.
Oh, wait.
So if I come up here, it's called wage.
Unexpected sender.
So here's a good thing, if you get an error, don't try to run everything at once. Okay, go ahead and just do the group by part and see if that runs without an error.
Yes,
And then the next thing is just do a summarize with that first mean and just close it and run that and make sure it runs. So it's divide and conquer here when things don't run. And then one by one, start adding each of these additional variables that you're creating for the two groups. And that way you don't have a lot of things moving while you're trying to solve the problem.
mine is an unmatched bracket.
Okay, it works.
Is that just
Brian,
come up? That didn't
Come
Or
in,
it's just a-
come in,
Okay.
I think it's supposed to be-
problem solve.
Issues.
Literally change your to computer
Got too many parentheses?
Yes,
On that, on this line 70,
'Cause we were still
go
running.
there, but before the pipe, put a carriage return before that.
what does that mean?
Just go return and then run that.
Okay.
Yep, all you, so everything
so
worked,
because you
okay,
got
so
this,
now pull the pipe up to where we
We've got
were,
the parentheses around that,
okay?
right, that R doesn't like that. If you wanted to make that kind of
So I
technically
think-
correct, you have to put a C in front.
Oh, right
You
here.
may have,
Yeah, no, in front of the parentheses.
you
Oh,
got too many
this- oh,
parentheses
wait,
right there.
here?
I'll explain that in a
So
second.
this one,
And on the top
Quantile,
one too.
yeah,
There you go.
see, I don't need this C because I'm just telling it a single value.
oh, okay, so
Do you know what the C that I had before was?
multiple.
That was creating a vector with multiple probabilities in it. It
Okay.
was the 5% and the 95th percentile. And now you can see that I just made it scalars. I didn't, because as Brian was saying,
I
the
put-
variable that, what that quantile function is creating now is just a vector that goes into, in that assignment there. And if I would use a C parentheses 0.05, it then gets the type wrong.
Okay, it's right.
What about Dion, what, does yours work? Yeah, yours works great.
Yeah.
Yeah. Brianna, yours work?
Yeah, I just got it.
Okay.
Thank you.
Questions or?
It was,
Yeah, good.
yeah.
Yeah, like Mark said, so the way that R works is it does things in like kind of like a linear algebra format where you've got like an element, kind of like an Excel, like a little chart, little cell that you can put a value in. If you wanna group those into multiple cells, it's called a vector. In R, you can use C, you can do X1, X2, X3, so on and so forth, right? So if you want to group those into one object, you can actually say that as, as a variable, right? And then you can actually go one step ahead, you can actually create it as a matrix. You can have a bunch of these kind of all grouped together into a single matrix. It's kind of a holdover from what R used to be like many, many years ago. Something you're just gonna have to deal with and kind of play around with a little bit, but if you're ever gonna group numbers together into one thing, right, you're gonna use that C parentheses, and that'll allow you to put it all together.
Okay, so if we look at the results here, south versus non-south, do these numbers say with regards to the average and the median wage kind of agree with what you thought would be the case before we ran these?
No,
Why not?
well,
So how much do on average people in the south make less than the people elsewhere? Is that,
Like less than $2. Kind of.
yeah, it's about $1.50,
Yeah.
right? Now, you could conclude that and say, hey, the question is, okay, this is just simply comparison. But then I have to deal with variance, right? And that comes into t-statistics and things like that. So to be able to really conclude with statistical significance whether or not these are different, I would then have to use the standard deviation to then compute a test statistic, a t-statistic, that would then give me statistical inference around that, rather than just simply saying, yeah, they're bigger, but I can't say if it's statistically significant for the wages that, for non-south wages. Also, you look at the standard deviation, there's more deviation in the wage in the non-south than in the south. Also, you see that it's skewed a little bit to the right relative in the non-south relative to the south. And so nothing there really suggests anything that I would not have expected. All right, there's another example in the slides about unions, but I think in the sake of time, we'll jump past that. But this is generally the idea, is we're computing a summary statistic, Y, conditional on some kind of category X. Okay? And all we're gonna be doing is using group by the category X, and then using a summary like the mean, given that categorization of the Y. The problem that you run into is sometimes you have variables that just aren't categorical. So, what about education? I think that's. So this is, what if the group is not categorical? Well, then you've got to create a category. And if you think about it from a wage standpoint, we could ask the question around this of, are older people earning more wages than younger people? But age is older, but it's an integer. What would I do? What would happen as I group by age?
you're gonna have groups for every age.
You just have so many groups, there would be no information in it. I may have one group of say an 18-year-old, there's not a lot of them there, and there would just be one person, that would be a very good representation of their wage, right? So, what I want to do now is I want to group the people by their age. In other words, or excuse me, I want to group people by whether or not they're older or younger. How would you think I could create a category variable using my age variable to come up with older versus younger? Could I just split the sample in half? Call one old, call one young? Would that work? That would be a category?
Yes,
How would you want me to split it?
mutate if,
Think about it just not from a coding standpoint, just think about it from, who would you define as being old and who would you define as being young? And everyone has to belong to one or the other.
Well, like,
50.
like surveys are
well,
like
it's
55
from
and up, it's like,
18 to
oh,
64,
right.
so maybe like.
You could just arbitrarily just chop it in half and say, hey, I think people younger than. So what I'm gonna do is I'm going to use the average age of my sample as the dividing line. You okay with that? Do you have problems with that? Some people might, especially if my average was really screwed up, because of the sample that I have. If that average happened to be 25, do you think that that would be representative of older people?
No.
No. Another thing that I could do is I could just simply use what the Bureau of Labor and Statistics does. They go from 16 to 24. I'm not gonna do this, but they go from 16 to 24, 25 to 54, 55 to forever. And those are the groups. Okay, and we could categorize based upon this if you wanted to. What we're gonna do is we're gonna make it simple. We're just gonna take, hey, if you're younger than me, you're young. If you're older than me, you're old. But that's a critical decision. You just can't just say, hey, wave my hands, this is what it's gonna be. Those are the type of things that you have to think about when you're working on your project. Okay. All right, so, category of old and young education. Is that what,
Mhm.
wait, sorry. Jumping ahead in my head. Okay, so we know we're gonna be using that same CPS data. Go ahead and map that in. And we need this new category variable. So we need to mutate. And we're gonna create, call it age type. And that's going to be using the following is young is less than average age, and old is older than or equal to average age. Okay, so how do I do that? Well, that's that if else command that you've been introduced to. So if else, in this case, it's going to be age less than the mean of age. Right, yeah. And then I have to tell it what those categories names are. If it's less than the average, it's gonna be young. If it's greater than or equal to the average, then it's gonna be old. And everything matches up here. So does that work for everyone?
Yes.
And if we go back and review what the else age, the else if command or if else command says, is it evaluates this logical operator And if it's true, it assigns young to it. And if it's false, it attaches old to it. So let's just run that part. And I'm gonna go ahead and put in CPS age wage. Because I want to be able to print things out to see it. And I hit return. I don't get any errors. And all I'm gonna do is down here, I'm gonna put in head of CPS age wage and see what I get. And here's my new one right there. And if I look at the first individual, his age is 35 and he's defined as young. The guy who's 57 is old. These other ones look pretty reasonable. So I think I did it right. Leah?
I get an error that says unexpected else.
Expected,
It says unexpected else.
unexpected else, oh no.
I just put too much space in it or?
Oh, underscore, if underscore else.
Yeah, it's kind of,
There you go.
that work? Everyone else okay with it?
Give me an excuse to go get a donut, so thank you.
All right, so I know that I created the category right. So I'm okay with that. And so now what I want to do is I want to group by that, put them in their categories, and then see whether or not older workers make less than younger workers. How do I do that? Well, I'm just gonna pipe it in. And go ahead and group by age type. Pipe that into summarize. And now I'm gonna just calculate age, or let's just go, mean wage. And in the interest of time, I'm just gonna do that here. We could do more summary statistics, but I think that that's where we. And so if I type in the name of that, age, wage. Oops. I can see that, what's the case? Old people make more than young people, not surprising, right? And so I was able to overcome this continuous variable problem by creating a category that is based upon being old or young. And everything's there, so you can look at the other summary statistics where I look at the median, the standard deviation. You get these things here, okay? All right, I think we have enough time. So I want you to do the following. I want you to answer the question of whether or not older individuals are more likely to be married than younger individuals. That means I have to have the married category, but then I also have to think about age. So age was not a categorical variable, we just created one. Again, in this case, we're again talking about older versus younger. So that's the groupings. And now I'm going to apply those grouping to whether or not you're married or not. So you can use what we just did to define the category around old versus young. But the twist on this is we've been looking at the wage, which was a continuous variable, and just applying means and variances and things like that to it. Now we're looking at married, which is a categorical variable. And I wanted to show you just quickly. If I come in here again and do married is the last one here, it's a factor, has two levels. I'm either married or I'm not married. If I'm not married, it's a 2. If I am married, it's a yes. One of the things you like about binary outcomes is I can think about it in a probabilistic sense. If these had been defined as 0 and 1. So what you need to do is you need to define a new variable for married that creates 0 or 1. So here's the problem. Do you want to take a stab at it?
Do you have to put like true equals, true would be like a yes or no?
We'll come back here and look at what we did to define age type, young or old. We use this else if. So you could do the same thing with marriage, because these will turn out to be 0 1s, won't they, Brian? If I did it on you can just come in here and think of if I'm gonna create a new marriage type, and I'm gonna say, if you're married, make it 1, otherwise 0. That makes sense? So this is really all the commands you need. You just need to add a new mutate to create this new marriage type that creates 0s and 1s. Where 0 is if you're not married and 1 is if you are married. And then everything else works here. But you're not looking at wages, you're looking at married on the new created variable. So take a stab at that. We'll give you a, say, till, let's go to 10-2. And if you have issues, raise your hand, or you want to talk it through. This is not like an isolation tank. I'm more than, Brian and I will talk to you about it. Brian, why don't you do Leah and Brianna, and I will do Dion and Taylor.
So this is whether we're saying they're not married. We're just trying to
Yep,
get
you got
to
it right.
the word form.
The only thing is, I don't know if that's gonna work. Mutate can do multiple mutates at one time, so instead of piping it, let's get rid of that and then just put a comma. Yeah, you're missing comma, and then let's define the new one.
Oh, you don't have to.
You don't need to mutate. Get rid of that parentheses and then you'll be okay. Cool. Okay, and then, that looks good, but it needs to be a logical statement, which means that you need to have 2 equals.
Stuck.
Oh,
Yeah.
I can see you're stuck.
And
All right, we're on.
married
All right, so you get
is
all right,
is a
so
character. So it's not 1, it's gonna be
good.
yes or no. See how it says
So,
down there? It's
So we want to
Yeah,
keep our.
Mary
So I
is
don't have it open your eye, right? So let's keep the old and young that we had before, so instead of calling it marriage type, let's keep it age type.
How's yours?
I don't know too.
Now.
I
see how
tried
you
to
tell
make a
the
new
parentheses
column saying
for your
if-
type there?
If they're
Put a
married,
comment
or if
between
it's
them.
yes.
Yep, you're on the
Because
right
you're-
track, but when it's yes, make it one.
Okay, and then,
And it's a number, so you don't need
Now,
strings.
marriage
Does
type.
okay,
that make sense?
Oh, I have,
yes.
so I won't need another if else, no, I do.
No, you'll need the if else.
Type of- let's do,
Okay, if else,
series
married
is,
is equal to
Here,
we have
2, which
marriage
is
here.
yes,
Let's just
and then
use here.
now you want it to come out
No, no, no,
as 0,
that's fine,
1.
that's fine, that's
two
fine.
is no,
Here, and if else, online.
one is yes.
One is no, because it comes
Now let's go down
first.
here to marriage type.
Oh.
And
So
2
it's
is yes.
So how come on there, like when you're reading on there,
I-
it says no, yes,
I don't know
and
what
two,
it's
two, one?
Because that's the way that
Oh,
individual
it's in the
is
down.
married.
Okay,
Now do your if else.
so
Question.
one.
Wait, did the lecture
person.
size grow?
One
Um,
is
no,
yes.
one is not
Beautiful.
married,
So one is no.
but no, what we want to come back with,
Now remember when we
with
wanted to do
numerical
equality,
values.
we do the two
Oh,
equals.
not whether it's no or
You don't
no.
want a character,
Equals equals
we already
yes.
have characters.
Oh.
So what you want, because we're gonna have,
So
we're gonna
equals
apply
no.
an average to it.
Yeah.
So what are you calling,
Right.
so you got married, married, so remember married is a category, which you converted to a number,
yes?
married val.
Oh, okay.
And yes is a
Oh.
character, so what do you need to do with it?
Okay.
Do I put
Okay,
yes?
now, you don't want
Yes,
characters to
yeah.
come back, you want it to be values, and so you put 1,
Comma,
Oh, this.
Yep.
thing?
you just don't make it a character, just
No,
make
no.
it a number.
0.
1,
You only have to do one?
No, so
Oh, you could just
what
put
that
one
statement
and two, you
does
don't have to
is,
put in.
put
if
1 and
marriage is
0.
equal to yes,
You don't want it
I
to be,
want marriage type to be 1.
Okay,
Not
so
yes.
married,
I want
put
it to be 0.
one,
that's your
not
new
married,
variable,
put 0.
Yep. And you're gonna still, you're not gonna group by that, because that's your dependent variable is married.
Group by
What?
age.
You wanna do that.
Okay.
How did it work?
Well, I only did this part, so,
Did the variable that you create look right?
You have to close out the mutate. After the.
It should be at the far end.
So you have marriage type equals if else.
Married, yeah, because the first
Here?
guy is
0,
married
1. Yep.
and it's a 1, 1, 0. So you got the right ones there. Yeah,
Okay.
that's work.
There you go.
Now go back and define the old and the young. You've already got that.
Okay,
you
sure.
said define the old and the young?
Yeah, you've already got it. You've already did it in our exercise earlier.
Here,
Yeah, and so you don't need another mutate command. You just put a comma and include it in the same mutate command. Because you're just creating another variable along with the marriage variable that you did of age type. So if you copy
You see what's happening?
the,
So you've got a pipe here, and you're doing a bond.
everything but the mutate.
Which you don't want to do.
so this,
So we want to group by
No,
the
no,
age
no,
type.
you were right, just everything that you
We're gonna do
highlighted
summarize.
before,
oh,
but
okay,
just not the mutate.
Not-
results.
okay,
And then
Yeah.
copy and paste that down
Whatever's in line 120.
and put a comma before the parentheses. Yeah, between the two parentheses.
oh, between them, okay.
And then and then just copy it in there. You can do a line return. Oh, you gotta, yeah, just delete that because you got too many parentheses. Okay,
Break out that.
get rid of the
So
parentheses in
you've got
front of
this
the H
assign
type and
operator
you'll
in
be
there?
good.
That's gonna be good right now.
Now run that and make sure you get two variables that match up the way
There
that
you
you
go. All
want.
right.
Okay.
How come
But
it
yeah.
doesn't show?
You good?
So-
Yeah, but when I,
All right, so what we got here now,
and it comes over.
right, so
I
we-
also copy.
Did you do group
That's
by?
fine.
Yeah.
So what you wanna do now,
You just-
right?
Create it.
I didn't get
You've got
that far
this
yet. I only
Age
did
type,
that right there.
marriage type,
But like,
age type.
it's still over here.
So we don't want them average wages.
Hold on, is
right?
that-
We just wanna take an average of this marriage type. So let's just do, what do you wanna call it?
On
So
your data,
mean-
did it add that
Can you
column?
run it up to this height
Original
here
data.
on 101?
Give the name.
Oh, God.
Before Yeah, before the bite, right there. Let's just see what your data looks like.
It's not adding anything.
The summarize is fine,
And
so
go
you
all
see a
the way up
mean
to
wage.
right.
Let's go. Let's do mean of our marriage underscore type. Let's just get rid of all that stuff.
Okay,
We just wanna do it.
So- the married value looks right. Okay, go back to your code.
And actually, just as a, you don't have to put the dplyr, whatever else.
Oh, you know why? You're redefining
Okay, here we go.
mean val, mean married val.
You know what we group by?
Saying,
Group by married. So
that
married-
summarizes is almost like a mutate command.
There we go.
But it's mutating based upon the groups. And so
There we go.
you've got to have a different
So
name
let's just go ahead
here
and view all
So-
our GC
for like mean,
Mhm.
mean,
There you go.
median, standard
So,
deviation.
it looks
So like mean married.
So we calculated, so
Okay.
what that did
Yeah.
is.
Otherwise,
it calculated
What happens is you got it
The
here
average
and then
of
you
the
wrote
0
over
1.
it and then you used it
Trying to
here and
get
said,
people like
hey, I
that.
don't even
So
know what you mean.
In our sample, right, 77% of old.
So now
people
we just wanna
and
group by
56%
The
of
age and
Young
me.
people.
Just group by the age,
And so if you wanted
And
to
then
do like
calculate
standard deviation.
the
or
average
whatever, right,
marriage
in this summarize.
based
you could
upon
just
the
accept
grouping
that.
by age. So pretty much what we did right there on lines 97 and 99, 98, 99. That's exactly what you'd be doing, but instead of
Do like SD.
doing it on wage, you would be doing it on marriage, on that new marriage variable that you created.
You got it.
So group by age and then do all your summarize on the new variable for
Good.
marriage.
Okay.
You getting an error?
One.
So your summarize command
It should.
isn't, look at the summarize command up there.
Yep.
So it's doing mean wage is equal to mean argument of the wage. So do that now for education.
Okay.
Do it for-
March,
I did. Go back to your, see, and I get 2 columns.
Oh.
Yep, there you go.
Yeah.
It can't be the mean, because it's only saying.
No, this is, so that's why we wanted it to be 0 1s for marriage. We want them, because the nice thing about when you're dealing with zeros and ones, when you add them together, the ones, and divide it by the total, that's a probability. If I do that with ones and twos, it doesn't work. Zeros and ones work. Because I'm looking at what's the probability of being married if I'm old. If I take a bunch of zeros and ones, the ones that turn out to be
Oh, and it's gonna
ones
say your probability.
will give me a probability.
So what is this? Sorry, this is saying the probability of being old and married.
Yeah, so that can't, yeah, if it were right, but we're running into problems because the two outcomes sorted and grouped by old and young for the average marriage has to sum to 1. Is that?
What are you talking about now?
Did you get it to return something after you group?
Well, is she trying to use the adorn?
Group
or
by
is it-
age?
No, I
Group by age.
need to.
Oh,
Goodbye, age type.
okay.
You're right, Taylor.
Oh,
I was thinking about it in an unconditional sense. Since this is conditional,
Yeah,
I need to remember that the old people need to sum to 1, not the old and the young. Conditional on being old, those who aren't married versus those who are married, the probabilities of those should add to 1.
if you wanna know what's like working in research at any Fed, like this is the exact conversations that happen every single. You'll be at lunch and you'll overhear us. What are you conditional? These are unconditional. No, you're conditioning on something.
Leon, did you get it?
chairs get thrown.
So I group by
That's
age
right.
type.
Okay.
So that's what happens.
Yeah.
I don't know,
And your
Brianna has it.
I've
Well,
heard,
that, yeah,
it's
you know,
good.
okay, you group by
It's just
age
put a
type.
parentheses.
We're here.
Mary, this one you put a parentheses over this.
You need an ending parenthesis. You don't need that parenthesis, and you need one out there.
Okay, Brianna,
No, that one you needed,
you got it.
that's the one you don't need.
This one.
Yeah,
You just need to slow down.
and then you close it out and I think you're good.
Just slow down, you're good.
Okay, now,
You try to outrun the program.
Yeah.
There you
oh,
go.
you didn't pipe it.
Over here.
Yep, you need to pipe everything to that group by. No, you're good there. You just need to put one right there.
By the way, we're gonna blow your minds on the homework.
You always say that every
Now-
meeting. I'm actually not blown away. I'm
Tell
pretty
me what that
stressed out.
name is. You just need to, just
We're gonna
repeat
stress
that
you out for this. meeting.
CPS marriage age down
We're
there.
gonna do it in our mark.
Because I'm just printing it.
Repeat.
No, just
Oh,
on line
hurrah.
102,
Don't worry. We walk
type
it.
out that CPS age
You said that.
marriage.
You did great. You guys have done fantastic in your homework.
Go right there, just highlight that, click it, and then hit control return.
Genuinely impressed.
It takes like 2 hours a day.
Literally.
Okay,
The first,
so
it'll get easier, I promise.
I don't understand.
I think
Never do that again.
I can't do it that quick, but so I think most of you did meet, right? So the only thing that you're missing from this table is the median and the standard deviation. So all you need to do then, oh, well, this is a good point. Why is the median 1? Because all these variables, if you're married, is 1. Right? It's 0 otherwise. And so all it's doing is sorting from 0 to 1. So that just tells you that, it's always gonna be 1. It doesn't make any sense here to really do a median.
So, like, I'm not understanding this, like, the mean.
Yeah, so let me try to do it this way. I know how you loved your probability and statistics class, right? But if I have a binary outcome, which being married or not being married is, then I can use. If I flip a coin 4 times, if I flip a coin 4 times, 2 of them become tails and 2 of them are heads, what's the probability of a head in this particular case?
50,
Okay, how did you get that?
4, there's 4, and then 2 and 2.
Okay, that's what you did,
Yeah.
okay? So you said out of my 4 trials of flipping the coin, I got it twice. In that case, you're flipping a coin. In this case, you're getting married or not married. So if I give you, something like 0, I don't even know what this is, we'll just have to figure it out. Tell me what, and that's my outcome for my tail, I mean, my head toss. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 trials. Can you tell me what the chance, what the probability of getting a head is in this particular trial?
50,
Hmm?
50,
50, and how did that happen?
tails.
I added 1 to 1 to 1 to 1 to 1. That's exactly what you're doing here. Because you set it up to be 0s and 1s, you can take the average. What's the average here? 5. Or no, excuse me, 0.5, because I just add all these things up. And I don't have the notation. But the average here, or mean, of that is 0.5.
So, I
And
don't,
that's all you're doing there, right?
Yeah.
You're taking the group of those people that are old. They have a bunch of zeros and ones, and you just computed that by taking the mean.
okay,
That's why I didn't want them to be ones and twos. Ones and twos here are hard to understand. But you can, Taylor told it to me, everyone else understood it, right? In terms of, hey, if I get ahead, I call it 1, if I get a tail, I call it 0, and you instantly told me what the probability was. Wasn't complicated, you just looked at it and said, oh, that makes perfect sense. Same idea.
okay.
Zeros and ones are easy to work with, ones and twos aren't. You always take your stats class and say, hey, let's call tails ones and heads twos, because no one would learn binary outcomes that way. All right, so we didn't get through everything, that's not a problem. I think it's better for people to understand than to just cram through. There's this bank wage data, nothing really new there in terms of what we've already done. The important part here is all about, group by summary or summarize. That again, that is your meat and potatoes, things that you want to be doing, things that you want to understand. If you go through, there's another breakout session that talks about how you can look at the job types within this data frame called bank wages. Same kind of idea that we've already done. So there's nothing really new there that we haven't done. There is a part that gets into this education, and I think that this is one of the things that, I wanted this to lead into. Where we didn't do this for age, we could have, and we used this notation case when. We would have said, when case when number of years of schooling is between 16 and 24, I would call those young. This is prime working age, these are old people. And I would use that in the same context as I do here, where there's tilde 1, tilde 2, tilde 3, but I only have 3. This is education, and all it's doing is defining high school graduates, a little bit of college degree, bachelor's, well, is that right? Less than 12 didn't graduate, right? Graduated, little bit of college degree, advanced degree, or went to advanced. And then they just simply, all I'm doing here is simply giving it a name associated with it. And that's why I'm taking education and breaking it up into groups. And then I can sort by education type to know whether or not someone who didn't finish college or didn't finish high school with regards to, say, wage is, makes more or less than someone who did finish college and high school. So take a look at that. And then I will get you your projects and your assignments to the to your mentor probably on Tuesday. Okay. Any questions? We're always here to help.
Do you want to talk about the homework real quick?
Brian's gonna talk about the homework real quick.
The homework won't open, yeah, you can't open it,
Can't open it.
no,
It's an RMD file.
yeah.
You can open it in RStudio. So
I don't know if I had, well, I wish I had it. I mean,
I got online. Install it real quick.
where?
Well, it should be in, go into the fall 23,
Oh, that's right. So let's do this.
not that one, the other one.
No problem.
Yeah. fall.
I will-
Go to lecture 3.
You know, I'm not gonna do it.
So for homework 3, you're going to do everything in R instead of using an R script, you're gonna use what's called an R markdown file. And what an R markdown file does is it allows us to create really pretty, looking professional documents inside of R, and we can actually type our code directly into the document, and when what we call render or knit is kind of the terminology we use, that document, it will take that R code and it will actually execute it for us and give us our answers.
It'll make it very pretty.
And it makes it very, very pretty. So fortunately for this week's homework, you're not gonna have to worry about how to like code these markdown files or anything. Like there's nothing new you're necessarily gonna have to do. You're just gonna do your work in a different place, basically what you're gonna have to do. So if you download that R markdown file and get it into RStudio,
You can't.
no one's got access to this.
I
I'll-
downloaded it, but I can't. I didn't.
Like when I click to download, it says,
Do
I
some
don't have an
error.
application, and I have to like go to the app store.
Oh, so what you wanna do is just save it.
Yeah, just save that.
And then you just read it into RStudio by uploading it, just like our data file.
How do you?
Instead of like opening it, just
Should
click.
give you an option to download. Let me see.
Yeah.
That's what it gives you.
Oh, it's not flipping up in your finder.
Do,
Oh.
you cancel it? And you should be able to download. Can you just click the download thing?
Okay, I did it.
There you go. There you go.
And
Gotcha.
then all you need to do, once you download it onto yours, is when you open up the new project for homework 3, upload it as a R markdown file. That's what the .rmd is referring to.
So
So, go ahead, I'm sorry. Question.
upload it in the, what you're about to show.
Yeah, you just upload it into your, whatever your.
Into the
homework-
workspace that you're doing for homework 3.
Can
You just do it, go to.
Oh, as a R markdown.
Mhm.
Yeah.
Okay.
Yeah, so let's say that you had let's say for instance, this was like your homework 3 project.
Oh, based on here. Oh.
You would just do like an upload, choose file, right? You choose your R markdown file and upload it. It would show up in your directory down here. If you just clicked on it, it'll automatically open it up into your as an R markdown file, like you would like an R script.
Okay, I see
It
it.
would open up just like an R script. So you're gonna see a bunch of stuff in here that you'll type in yourself. So we've already got title homework 3, subtitle, we got 45, author, you'll put your name in there. Due date is next week. And then you just answer your questions as you normally would. So where you typed in an R script, your code, you'll just type it in here. So where it says write your code here, write your code there. Where it says, write your response here. So we may ask you for some analysis. Type it in as you would just a normal Word document. When you guys are done with doing your work, you type your code and your responses. You'll see a little button here that says knit up at the top here. It says knit. You'll hit knit and it's gonna do some stuff. And it's gonna generate this
See how
beautiful,
pretty it is?
I just blew some minds.
Mm,
I'm
So
looking
it
at,
comes
I
out
just,
just nice and clean.
nice and clean.
But there's some little things that you really need to be careful of. Tell them what they,
So the only thing you have to be really careful of is that you see these little 3 dashes here? Don't delete those are important. This tells our markdown that you're gonna start typing some code and it's gonna need to evaluate it. So if I delete one of these and I try to run this, try to knit it, I'm gonna get errors. So you get a bunch of errors.
oh,
See.
okay.
So
so,
just don't delete those.
so what's
Where do you
what's
write
in.
the code?
So when you write your code
Can I
here,
delete those?
you can delete
Yes,
this.
you can delete that, but here's the thing is sequentially save. Don't write over. Once you get part of your answer, you should knit it and make sure that it's doing what it wants. Do not wait till the end, because then it will be, it's just like coding.
Okay. I'm
Don't
gonna
knit
save
at the end, because all the errors could be, you don't want the bad stuff to all happen at the end.
So let's use this as an example, right? So in here I said data empty cars, and then I'm gonna just do a head of empty cars, right? That's just the data that comes kind of preloaded with R. Let's go ahead and knit that. Is it gonna execute? Yep, it does.
Very good.
No, it was, you just went to it.
1-3. Oh, sorry.
Go,
There you go, 1-3.
there it is.
See, data into cars, and it runs the code like, I thought I did it at 1.1. Right, so when you knit something, in POSIT, it will save the file down here as a PDF. It'll automatically output as a PDF. Some of you may have pop-up blockers enabled in Safari, and so you may get an error saying it's whatever, like it's trying to do a pop-up and it's being blocked. If you just look down here in your little files here, you should see the PDF file that you just click on it and be able to view it. But that's really it. So you're gonna do exactly as you guys did for your other homeworks. And I think what we're asking inside of this particular homework is pretty light. You should be, I mean, we're not gonna do anything
A
really
lot of the
complicated.
stuff we did today is not found on your homework.
This is gonna be like homework 1 type stuff. I think that's gonna, you're gonna find.
It's just helping you get into this.
Right.
This is really coming to the communication aspect of data analysis.
So when you get into your projects, you're probably gonna be doing most of your stuff in R Markdown. So if you just use this kind of basic template, right, to do your work, you can generate some really nice looking professional documents. So if you go into SSRN or even Archive or any academic document, you know, report repository, this is the standard document format that is called LaTeX, right? It just prints out things very aesthetically.
Because cutting and pasting output from R into, you know, there's ways to make it look good,
Right.
but this is the most efficient, effective way to do a lot of this. And if you got this skill, it goes quite a ways.
It does. It goes.
Brian produces a daily dashboard that has been all automated this way. Yeah,
And I just tell it, I say, hey, here's my data, just spit it out into a PowerPoint type deck, PDF it, and send it out to a bunch of people that are on my list. And it does it all for me every morning at 5 AM. And when I wake up or get in, whichever comes first, so you should not awake when I get in, I'll check the charts, make sure that there's no errors, that there's no issues with the data, something happens, something goofed up. You know, I may have to rerun it, but it's really convenient because, again, like it gives me something that's automatable. I'm using the data that I have in R. I don't have to insert myself into the process where humans equals errors, right? General rule of thumb when you're doing this work, anytime you gotta insert yourself into the process, that's where an error is going to occur. And it just looks nice, it looks professional, it looks pretty. So, and then when we do our next lecture, we're gonna get into R Markdown kind of more deeply, but this is just to ease you guys into it.
without having to think a lot about coding. and things like
Yeah, you're not gonna have to do any R Markdown
that. So you
coding.
just click and type,
Yep.
so.
And we'll have office hours, so if you guys who have questions, or you run into problems or errors, we're around. So,
Yeah.
so let us know.
Brianna Taylor, do you wanna try to get your ID
Yes.
badge? All right, well, enjoy your weekend and the Labor Day holiday.